Hey guys, welcome to week 2. So the agenda for the week looks like this. We are going to focus on unit 21 of your textbook. So unit 21 is focusing on how to read and interpret drawings for roof trusses. So what we'll do, guys, is we'll start building off of last week's content. All right, so we were introduced to roof trusses and some of the key terms. And then after we get done with this week's reading, the first assignment that I'm going to ask you guys to do is the assignment is called How to Read a MyTech Drawing. So what we're going to do is we're going to click on that link and answer those questions. And then the second part of the assignment is going to be interpreting then a plan for a property located at 2130 Kane Street. So those plans are going to be inside this folder, and there's also going to be some questions on that particular property, and both assignments are going to be worth 30 points this week, so it's a little bit different. And I'm also going to do this. The first video that I'm going to be doing today is going to be just strictly on how to read a MyTech drawing, and then look for a second video on how to then take that information, guys, and interpret it when we're reading a truss plan. Okay, so if you go inside the folder here for week 2, you're going to see, both your assignments, the MyTech questions, and then the second part of it. Here's some key points. I have the how to read a MyTech drawing, and then the plans for the second part of the assignment are right here. All right. So in going over the PowerPoint, what you guys learned from last week was what a MyTech drawing is. So, it's created by software, and it takes the dimensions of your house, and then it designs the trusses based on that information. So on a truss plan, what's typically going to happen is you're going to get a truss delivery list, and so you're going to have 2 main components in that list. And so one is just going to be the layout of where the trusses go, but the second part of it is going to be something called the truss engineering sheets. All right, so these engineering sheets are specific to each truss that is in your actual plans. Okay, so understanding and learning how to read a MyTech drawing is exactly that. It's looking at the truss engineering sheets and picking out certain information based on that. Okay, so what I'll do here is I will go into the how to read a MyTech drawing, and so you're going to have guys, when you get a set of trusses delivered, you're basically going to have the truss plan, which basically looks like this, and then you're going to have a set of sheets on each individual truss. So MyTech has this little cheat sheet, and this is what we're going to actually be going over today. Now, there's certain information that you guys are going to need to know when you are setting trusses out in the field. All right, now my job here is to basically explain to you what I think are some of the most important things to look for. And so before we start, I think we'll just kind of go over this top section here. So every truss is going to have specific information. You're going to have your job here, and that could be listed, either by a number or something like that. You're going to have the truss. So, for example, truss A1 or A2 or A3, depending on where you get them from, this is, going to vary, but it's typically, letters in front of it with a number. And then the truss type, so it's going to tell you what type of truss it is, how many of the trusses, okay, and then the ply. So one ply just means it's a single truss. So if you saw something that said 2 ply, that would be 2 trusses probably nailed together. So typically you're going to see stuff like that with like girder trusses. And then the information would be any sort of job references or any other notes up here. So here's an example of a truss right here. This is 1623 Liberty Street, which you will see in your folder as an example. So here I have, the job number, the truss, which is A3, truss type. It's a common truss. So if you look at this truss, it's basically, I'm sure you've already guessed by now, it's a gable truss. A common is a gable. It looks like there's 6 of these trusses. There's 1 ply, and then there's no other information in this job reference area. Okay. So what are we really looking for when we're looking at these sheets, right? So there's a couple of things that right off the bat I want to start showing you. So when we're looking at figuring out how to read this, you'll notice that on the left-hand side here, there's a whole bunch of letters. So these letters are going to correspond with certain areas on these truss engineering sheets. So one of the most important things I think you need to know is, first of all, how wide is the truss? So what is the truss span? Okay. So in order to do that, I want to show you, so I'm looking at how wide this thing is. So let's look here, and we're just going to go down, and I know that the letter G is going to give me information about a truss span. And so what's important to look at here, guys, is this. Trusses are going to be listed on these sheets in feet, inches, and 1/16 of an inch. Okay, so if I were to blow this up and I were to go in here and I would look at the letter G, from the very outside of this wall to the very outside of this wall, G is 30 feet. Okay, so I know that this truss span is 30 feet. Okay, if the truss said 10 feet 1-3, what that would mean, it would mean 10 feet 1 3/16 of an inch. All right, so this last number here is going to be the 1/16 of an inch. So if it's 8/16, we're really talking about 1/2 an inch, right? But the engineers, for whatever reason, list things in 16. So when we need to know information about the span, that's where we're going to get that information, okay? What about the total height of the truss? Okay, that's another key thing. So why is that important? Well, I want to know how unruly these things are going to be to actually stand up, all right? And then how, what the span is. That's going to let me know or determine if I need to rent a crane or something like that to actually set these trusses. So let's look at the truss height. So overall, let's see, it looks like letter E, overall truss height. That's going to be on this left-hand side. And I'll just blow that up here. Just bear with me here. So the overall height of this truss is 10 foot 1 3/16. Okay, so they're not too terribly tall. All right, so that truss is not very tall. If I were to go here and look at my example, 1623 Liberty, I have a truss that's 10 foot 0 2/16. All right, so basically 10 feet, and then 2/16 is really an 1/8 inch, so not too terribly tall. The truss span is going to be right here. So I have 35 feet 8 inches. Okay, so it's quite wide. All right. So those are two very important ones that I think you guys should know. Now, what about how much does this truss weigh? Okay, is it going to require a bunch of us to tip the thing up if we don't have a crane? So let's figure out where that is. And I kind of know certain information here. So we're going to go in this category here. So Y, truss weight. So this truss right here, the one that we're looking at in the MyTech example, is 182 pounds. All right. So it's, a couple hundred pounds basically. we should be able to manhandle this if we have to. So that's going to be the weight of the truss. If I need to know what the spacing of the truss is, truss spacing, that's going to be the letter J. So as you can see, I'm going to things right away. I'm a little bit used to looking at these, but so under the spacing heading, if we look at this, the truss spacing is going to be 2 foot on center. Okay, so that's an important category to kind of figure out. What other information is important? Well, let's take a look at truss reactions. Okay, now reactions is going to be right here, and this is the letter T. So what is a truss reaction? Well, the truss reaction is simply means this: how much weight is this designed for, this particular truss here, so that the weight is distributed to this outside wall and this outside wall. Okay, so trusses are designed for live loads and dead loads, and then they're designed to distribute the weight equally so that the weight is sitting on each of the walls. Okay, so why is this important? Well, if you had a structural truss, something like a girder truss, for example, we would want to really know how much weight is sitting on this outside wall, because it might require us to add studs underneath inside the wall cavity to transfer our load down to the foundation. So in this example, this is how you would figure out a truss reaction. So if you look here, I'll blow this up a little bit, there's always going to be like a number here. So on this side there's a number 2, and if we go to our reaction side, you're going to see that here's our number 2, and then equals, and this is the weight that's going to be distributed on that part of the wall. So it's 1,657 pounds. Okay, and then it says there's a slash and then 03-8. So this is, if you look here, S is maximum bearing required. So for this truss, the maximum bearing where the truss is actually sitting on the wall, 3 inches and 8/16, right? So 3.5 inches of bearing is the max. All right, so if you were to go to the other side here and you look for the letter or number 8, it looks like it's going to be the same thing. 8 is 1,657 pounds. All right, let's go to our example ones. So here, number 2, let's go to the reaction. I'm sorry, 17. 17 is 278 pounds, and then the other side would be 2,172 pounds. So you can see there's 2 different weights here. Okay, so it just goes to show you, how things can be different. All right, so here's 17, here's 16, and then if we go over to 10, on this far end, we have 1,574 pounds. So there's a bearing point here, there's a bearing point here, there's also a bearing point here, and then what it's telling you guys is there's a mechanical fastener at this particular end right here, which is in the form of a hanger. So I know that this truss is going to be hanging off of something, and 9 times out of 10, it's going to be a girder. All right? So there's 3 different bearing points on this truss. All right, so we're moving along here. So that's our reactions. One other thing that's important to be able to understand is any kind of bracing requirements. So the letter U on this sheet is required member bracing. All right, this is the area where you're going to get bracing information. So what do I mean by bracing? I'm meaning inside the truss, where, if any, is the bracing going to be required. So I'm talking about either lateral bracing or T bracing. Those are the two different types of bracing that you're going to encounter. So let's look at this example right here. So here we have bracing for this particular truss. It's an A3 common truss. And what I'm looking for and what I'm actually going to show you here, guys, is this. So the top chord, it says structural wood sheathing. So basically the sheathing that you put on top of the roof is bracing the top chord. The bottom chord, it says rigid ceiling applied or 6 foot on center bracing. So inside here there's going to be some catwalk, and then it's going to be 1 row midpoint. So rigid ceiling, which basically is going to be the actual sheetrock from underneath. And then if you look in this section here, it says webs. It says 1 row at midpoint. Let's look on this. The easiest way to pick this out is if you look right here and you see this little rectangle with an X, that's depicting a stud. And then on both sides here, there's a stud. So if you were to set 6 of these up, guys, in a row, it would require a row on each side of the webs at midpoint of diagonal bracing, or it'd be not diagonal, but excuse me, horizontal bracing. So this would be called lateral bracing, all right? So it is required, and then if you look here, you're going to see it. So, you know, if an inspector comes out to the job site after you have your job, your trusses set, he's going to be looking for any areas like this for required bracing, all right? And lastly, the last thing I'd like to kind of get you guys familiar with is the actual notes section, which is W here. In this section, you're going to find any kind of nailing patterns or any sort of information that relates to, you know, stuff like say girder trusses, for example. It's going to tell you, you know, how to nail the girder truss, any other information, the design criterias, loading, that kind of stuff. So you can go down in here and pick out information, design that. So if you notice here, this is a bunch of stuff that I really don't even know what it all means, and it's telling you it's unbalanced snow loads have been considered, all this other stuff. This truss has been designed for basic load combinations. Refer to the girders for truss to truss connections, provide mechanical connection of truss to bearing plate, capable of withstanding a 100-pound uplift. So here we're talking about hurricane clips and things like that to tie the trusses to the wall. So what I'm telling you guys is you'll see certain information here based on that particular truss. So if we look at the truss example that I have here, and we go into our notes, you know, it's going to be very similar. So on this particular truss up here, I told you there was going to be a mechanical fastener. Here it's telling you, provide mechanical connection by others, which is a different manufacturer of truss to bearing plate, and it's telling you it has to be capable of withstanding 100 pounds of uplift. Okay, and so on your truss plan that you'll see, there's going to be a little area here for hangers. Okay, so this is the hanger that's going to be required for that particular truss. All right, so as you go, there's other things here, but those are kind of some of the major ones that I want you guys to start thinking about. And so you're going to always want to be looking at these engineering sheets for that type of information. So the assignment is going to be based on interpreting and picking out information on this MyTech drawing. So let's start to get familiar with it and start acclimating yourselves to finding, you know, really basic information. You don't need to know every single thing, but as carpenters, we need to know to look for certain things on here, okay? Certain things are going to stick out, and we're going to want to know certain information. All right? So with that being said, if you have any questions please, reach out to me, get a hold of me, or use the discussion board and watch this video, answer the questions, and then look for the second video on actually how to take that information and use it so that we can lay out and place the particular trusses in the particular order in which it should be placed, and then actually pick out information about the trusses for a particular plan. So the next video is going to be getting in kind of the nuts and bolts of reading and interpreting these plans and using the information. All right, so with that being said, that's all I have for this video, and then go on to video number 2. All right, see ya.